Welcome to the deep dive. Today, we're jumping right into large language models, LLMs. Basically, they're prediction engines, right? You
Right.
give them text, they predict the next word or token.
Exactly. And, anyone can write something, a prompt, but getting really good, accurate results, that's prompt engineering.
Right, designing those prompts carefully. It's not just typing a question.
No, it's definitely a whole process. Like the source material mentions right at the start, it's iterative, you try things, you tweak them.
And lots of things affect it, the model itself, how
Yeah.
it was trained, your settings, word choice.
Yeah, the style, the structure, the context you provide, it all feeds in,
Okay, so the material kicks off with this introduction, stressing that it's a process, and bad prompts lead to, well, vague or wrong answers.
which is very useful, obviously.
Then it gets into prompt engineering itself, defining it as crafting prompts to get accurate outputs for specific jobs.
Things like summarization, pulling out information, Q&A, classification,
Translation, code generation, all that stuff.
and it makes a key point early on. The model matters. A prompt for Gemini might need adjusting for GPT or Claude or, Lame or Gemma,
Definitely not one size fits all. You might need to optimize.
for sure.
But for this deep dive, we're honing in on what comes next after you've maybe picked a model. It's the LLM output configuration.
Ah, yes, the control panel analogy. I like that. It's about tweaking how the model responds beyond just what you ask it.
Exactly, because good prompt engineering also means setting these configurations right for your task. It really shapes the final answer.
It lets you fine-tune things, yeah, like how detailed should it be, how creative versus factual. These settings are your levers.
So let's dig into those levers. First up, seems pretty basic, output length.
Right, controlling the number of tokens in the response. Tokens being those chunks of text the model works with.
Like a word count, sort of, but for the AI,
Kind of, and there's a practical side to this. More tokens means more computation.
which means potentially more energy, slower responses.
Is it maybe higher costs, depending on how you're accessing the model. So length isn't just about the words, it's resource management too.
And an important point here, just cutting the length setting doesn't magically make the answer more concise, does it?
No, not really. It's more like hitting a stop button. The model just stops generating once it hits the limit you set.
So if you want a short, punchy answer, you need to ask for that in the prompt itself.
Exactly. Don't just rely on chopping the end off with the length setting.
When is this setting particularly useful then?
Well, the source mentions it's important for some advanced techniques like React, which we can maybe cover another time.
Okay.
But the idea there is you might want to stop it generating useless extra stuff after it's already done the main task or given the core answer. Keep it tidy.
Got it. Keeps things focused.
Yeah.
Okay, moving on from length. Let's talk about how the model actually chooses the next token, sampling controls.
Right. So the LLM calculates probabilities for all possible next tokens. Sampling is how it picks one from that list.
And the main controls here are temperature, top K, and top P.
Those are the big three, yeah. They let you control the randomness, the sort of unpredictability versus predictability of the output.
So you can shape the output's personality in a way.
That's a good way to put it. Do you want straight facts or something more novel? You dial that in here.
Let's start with temperature. What's the deal with that?
Temperature controls the randomness. Lower temperatures, closer to zero, make the output more deterministic.
Yeah,
Predictable.
good for facts, right?
Yes.
You want the capital of France, not a poem about Paris.
Exactly. A temperature near zero, which is often called greedy decoding, means the model almost always picks the single token with the highest probability.
Almost always.
Well, there's a tiny caveat. If two tokens have the exact same top probability, it still has to pick one. But generally, yeah, low temp equals predictable.
And high temperature.
That ramps up the randomness. The model becomes more willing to pick less likely tokens.
So more creative, maybe more unexpected.
Definitely. And if you crank it really high, the source says all tokens become almost equally probable. It gets wild. Good for brainstorming, maybe, or creative writing prompts.
The source relates it to the softmax function.
Yeah, it's a machine learning concept. Basically, low temperature sharpens the probability distribution, makes one option stand out. High temperature flattens and makes more options seem plausible. Certainty versus uncertainty.
Okay, low for facts, high for creativity, makes sense. What about top K and top P? They sound related.
They are. They both work by limiting the pool of tokens the model can choose from, filtering out the really unlikely ones before selection.
Ah, okay. So how does top K work?
Top K means you tell the model to only consider the top K most probable tokens. So if K is 10, it only looks at the 10 most likely next tokens and picks from that group.
So higher K means more options, more potential randomness or creativity.
Right, and lower K is more restrictive, maybe more factual. If you set K to 1,
It's just greedy decoding again, picking the single top one.
Ex-
And top P, how's that different? It's also called nucleus sampling.
yeah, nucleus sampling. Instead of a fixed number of tokens like top K, top P uses a cumulative probability threshold. You set P, say, 0.9.
Okay.
The model then looks at the most probable tokens, adds their probabilities together one by one, starting with the highest, until the total sum reaches P. It then only samples from that group of tokens.
So the size of the group can change depending on how probabilities are distributed.
Precisely. If one token is overwhelmingly likely, the group might be tiny. If probabilities are more spread out, the group will be larger to reach that 0.9 threshold.
So higher P generally means more variety, lower P means more focus.
Correct. And like top K1, top EO, or very close to 0, also effectively becomes greedy decoding because only the single most probable token will likely meet the threshold.
So which one to use? Top K or top P or both?
The source basically says experiment. See what works best for your specific application. Sometimes one works better, sometimes the other. Sometimes using them together gives the best result.
Right, back to that iterative process idea.
Always. And that leads nicely into how these all interact. Temperature, top K, top P, and even the output length we mentioned earlier. They don't work in isolation.
Okay, how do they combine? Let's say I set all three.
So in systems like Vertex Studio, the model first applies both the top K and top P filters. It finds the tokens that meet the K count and the P threshold criteria.
Okay, so it narrows down the list twice.
Kinda, yeah. It takes the intersection. Then, for that filtered list, it applies the temperature setting to do the final random sampling.
What if only, say, top K is available, or only top P?
Then it just applies that one filter first to narrow the choices, and then applies temperature to the remaining candidates.
And if temperature isn't available?
Then it typically just randomly selects from the tokens that made it through the top K and or top P filter. You still get some randomness, but it's based purely on the filtering, not weighted by temperature.
Interesting. What about the extremes, like temperature 0?
Temp 0, like we said, is greedy decoding. So top K and top P become irrelevant because it's always picking the single most probable token anyway.
And super high temperature.
Makes the temperature setting itself less relevant because it flattens probability so much. The selection becomes almost uniformly random among the tokens that pass the top KP filters.
Okay. And top K1.
Also greedy. Temp and top P don't matter. There's only one choice.
High top K.
It makes the filter very loose. Almost any token with a non-zero probability might get through.
And top P, sir?
Greedy again. Only the top token is considered. Temp and top K become irrelevant.
And top P1.
Also a very loose filter. Any token with any probability, essentially, gets considered before temperature is applied.
Wow, okay. That's a lot of interaction. So any practical starting points?
The source gives some rough guidelines.
Sure.
For something, coherent but with a bit of creativity, judge 10.2, top P 0.95, top K around 30.
And for really creative stuff.
Maybe push temp up to 0.9, top P to 0.99, top K to 40.
Less creative, more focused.
Could try temp 0.1, top P 0.9, top K maybe 20.
And for tasks with one right answer, like math.
Start with temperature 0, that greedy approach.
Those are helpful starting points. But there's a warning too, right? About too much freedom.
Yeah, but a good heads up. More freedom, higher temp, higher KP, longer outputs increases the chance the output might drift off topic or become less relevant.
Speaking of outputs going wrong, the repetition loop bug, that's super annoying when it happens.
Oh yeah, when it just starts repeating the same word or phrase over and over. Very frustrating.
Why does that happen?
Interestingly, the source says it can happen at both low and high temperatures.
Really? How?
At low temps, the model can be too deterministic. It finds a likely path, and if that path accidentally loops back on itself, probabilistically, it gets stuck.
Okay.
At high temps, it's so random that just by chance, it can randomly pick words that lead it back into a state it was just in, creating a loop that way too.
So it's not just about being too predictable, it can also be about being too random.
Seems so. It's about finding that sweet spot. Careful experimentation with temperature and top KP is key to avoiding those loops and getting good, varied output.
Which brings us right back around to where we started. It's a process of experimentation.
Absolutely. There's no magic formula for the settings. You need to understand the knobs and then dial them in for what you're trying to achieve.
Okay, let's recap this deep dive on output configuration. We saw that after crafting a prompt and picking a model, These settings are crucial.
We looked at output length managing resources, not just conciseness.
And then the big ones, the sampling controls,
Yeah.
temperature controlling the randomness,
Top K filtering by rank, top P filtering by cumulative probability.
and how they all interact in sometimes complex ways to shape the final output, influencing creativity versus predictability.
And the key takeaway is really that finding the right mix is experimental. It depends entirely on your task and what kind of response you're looking for. Understanding the extremes in interactions is vital.
So, for everyone listening, as you use these LLMs, prepping for meetings, learning something new, whatever it is, think about these dials. Think how you can tweak temperature, top K, top P, to really refine the answers you get.
Yeah, don't just stick with the defaults. Play around. And maybe a final thought to chew on. We talked about controlling randomness for text creativity versus factuality.
Right.
But how else could this ability to tune randomness in AI be used? Could similar controls guide AI in scientific discovery, generating hypotheses perhaps? Or in art, controlling the unpredictability in generated music or visuals?
That's fascinating. Applying these ideas beyond just language generation, something to definitely think about.